Hello everybody, I welcome you back to my YouTube channel. So in today's video we have this question that if x equals sine t, y equals cos 2t, prove that the second derivative of y with respect to x is equal to -4. Okay, so we are interested in finding this. Okay, now before we can find this, we first of all have to get our dy dx. So this is our main target. Okay, so we are interested in finding dy dx before we can find the second derivative. Okay, so this is what we are going to do. We are going to take each of these equations one after the other, and then we differentiate them. After that, we use the chain rule to get our dy dx. Okay, so the first equation is x equals sine t. Now we are going to differentiate x with respect to t, and that's going to give us, if x equals sine t, and then you have to differentiate x with respect to t, that's going to give us cos of t. All right, now this is derivatives of trigonometric ratios, so you have to actually learn that part before you can get this, but these are like basic ones you need to know. So if you differentiate sine t, you are going to get cos t. Okay, now we have another equation, y equals cos 2t. Okay, now if you are to differentiate y also with respect to t, that is going to give us, this can actually be solved by using the chain rule, but in this video I'm not actually learning the chain rule, so I wouldn't want to dig more into that one. So if you are to use the chain rule, if you differentiate a cosine function, you are going to get negative sine. Okay, so the angle still remains 2t, and then if you differentiate this 2t also, you are going to get negative 2. You are going to get 2, so the 2 will come and multiply this whole thing, then you get minus 2 sine 2t. So this is dy dt. All right, now we are interested in finding dy dx. Okay, now using the chain rule, and then based on the parameters we have over here, our dy dx is going to give us dy dt times dt dx. Okay, so that these two parameters will cancel out, then we are going to have our dy dx. Now we have our dy dt, from our solution to be dy dt is minus 2 sine 2t. Okay, so times dt dx, we don't have dt dx, but we actually have dx dt. Okay, so if you have dx dt and then we want dt dx, that is the reciprocal of dx dt, so that's going to give us 1 over cos t. Okay, so we can actually simplify this. Sine 2t is a compound function. Okay, so if you expand sine 2t, you are going to get 2 sine t cos t. So that one multiplying 1 over cos t, we can see that these two can cancel out. So negative 2 times 2 is actually negative 4. So you are going to get negative 4 sine t. So this is dy dx. Okay, now remember from the question that x is equal to sine t. Okay, so we can replace this sine t with x, so our dy dx is going to give us negative 4x. Okay, so since we now have dy dx, we can proceed to find the second derivative of y with respect to x. That is d square y over dx square. Now if you have negative 4x and then you are differentiating negative 4x, you are going to get negative 4. Okay, so this s will just vanish, and then I'm going to get negative 4. Okay, so this is basically how you can go about the question. Okay, so thank you for watching, and I'll see you in my next video. If you have any suggestions, please do well to drop them in the comment section. So thank you and goodbye.